Here's an electrolysis problem where they give us a mass of the substance we're producing, bismuth, and they tell us the current, 25 amperes, and they're telling us what we're electrolyzing, BiO with a plus sign. A couple of tricky things. First, an ampere is a coulomb per second. So 25.0 amperes would then be 25.0 coulombs per second. The other tricky thing is in BiO+. We need to consider what the charge of the bismuth ion is within that. It's a polyatomic ion, not a very common one. But if the more electronegative atom would be oxygen, and you've got one atom of bismuth and one atom of oxygen whose oxidation state is known to be -2, that can be set equal to the overall charge, which is a +1. So then just solving for x, you've got x plus a -2 equals 1, x equals 3. So bismuth is a +3 in BiO+. Okay, so we're producing neutral bismuth, so you can say that for every 1 mole of neutral bismuth, it takes 3 moles of electrons to neutralize Bi with a +3 charge. So Bi3 plus and 3 electrons neutralizes to neutral normal bismuth. Okay, so let's start our problem. They gave us, my red number was 40 grams of bismuth. And we've got to look up the atomic weight of bismuth, 209 grams. That's equal to 1 mole. And then, based on what we found here, we'll set up a conversion factor that allows us to cross out moles of bismuth for moles of electrons. And then Faraday's constant allows us to relate moles of electrons to coulombs of charge, 96,485. So Faraday, you probably remember this one from earlier. 1 mole of electrons bears 96,485 coulombs of charge. And then our definition of an ampere above, in this problem it was 25 amperes, so that's 25 coulombs equal to 1 second. Now we're in the frame where we could stop here and get time, but WebAssign is a little more specific. They want the unit for time to be in minutes, so we're going to carry this one step further, allowing us to cross out seconds to get to minutes. So if you follow the units, grams of bismuth goes away, moles of bismuth goes away, moles of electrons goes away, coulombs goes away, seconds goes away. The only thing that's not crossed out is minutes. And to get that, multiply all of the numbers in the numerators all the way across. It's a big, monstrous problem. And multiply all of the numbers in the denominator all the way across. It's a big, big number. And then divide the top result by the bottom result, and we get 36.9 minutes as your final answer.